Okay, I've got 2 comments that I make to every single student I see, but they're still true, is that it is going to help you if you write down what x is. So in a binomial distribution, x is the number of explain what success is, the number of successes out of how many trials are you doing. And in normal distribution, it's the height, the volume, the weight, the time, the something continuous. 2 reasons for that. One, it's going to help keep control of what's happening. And subsidiary to that, and especially, it's going to keep control of what's happening if the examiner tries to trick you. Because a very common thing where we would say, I see you, examiner, or hopefully we would see the examiner doing the trick, is that in part B, they change it. And they go, oh, now I'm talking about Welsh men, or now I'm talking about women, or now I'm talking about meters, or feet, whatever. Something about this will change so that it's not actually x that we want to use, it's a new distribution y, but because we've been using x all the way through the question, we just think we're still using x, and then we go ahead and use x. So that is an absolute classic way to get students to drop marks, is to slightly change the thing that you're using to find probabilities. And without that discipline of writing down that every single time x is, you're gonna slip up when they put that trick in. Now the other thing is, I see that you've written down what the mean is and what the standard deviation is. That's great, and it is the standard deviation, but they want to see what distribution you are using. So writing it in notation, same with binomial. And don't forget, it's the variance that goes in there, not the standard deviation, the variance. Then they know that that's what you're using, and there's sometimes a mark just for using the right thing. So the question says, find the probability that all 3 men, well, we can't do all 3 at once, we'd have to do one at a time. We can take one man and find the probability that that man has a height less than 194. I think that might be what you've done. So the probability that a man chosen at random, aged 25 to 34, has height less than 194, we've just put this straight into the calculator, norm PD. Don't forget you put in standard deviation in the calculator, not variance, and then it will give you a probability. I'll check that later, that's the right probability. But that, you haven't answered the question. You found the probability that one man is less than 194. It says find the probability that all 3. So this is kind of a current bun question, really. This is the current bun questions of the where, maybe I should call them Russian doll questions. I might switch to that. They're only called current bun because I happened to see a question about current buns that was like this, but they're kind of more Russian doll questions. The thing that we are actually trying to find here is, I'm going to let y be the number of men aged between 25 and 34, English men aged between 25 and 34, out of 3 who are less than 194 centimetres tall, comma, out of 3. That's what I actually want to find. That distribution, y, the number of, that tells you that it's binomial. I've got 3 men. Success is being not less tall than 194. The probability of an individual person being, an individual man who's English, who's between 25 and 34, being less than 194 is that P that you just found. So this is why I would call this usually a current bun, but I'll try and switch to Russian doll. This P that you have found relating to that X, which is the height of an individual person, that then goes in there. And now the actual question. The actual question is, what is the probability that Y, i.e. the number of men who are less than 194 centimetres out of 3, is 3. Find the probability that all 3 men are less. Yeah. So we want to find what is the chance that Y is 3. Now, you might say, wait a sec, it's not that complicated. I don't need to think about a Russian doll of, you know, like, so the outside is the actual question, the one about y, the one about the binomial. And then the inside is where you have to find p, which is the p for the binomial, which is the probability that x is less than 194. Now, because this one says, what is the probability that y is 3? When you've got a binomial expansion, a binomial distribution, and n is 3, and you want the probability that y is 3, so that's basically the first one is less than, and the second one is less than, and the third one is less than, then you could think of it just in terms of a sort of tree diagram. So the first man is or isn't less, second man is or isn't less, third man is or isn't less, and what we want is to follow the trail of less than, and then man 2 is also less than, and then man 3 is also less than, which is going to be that probability that you found, assuming that's the right number, cubed. That's part A. Okay, let's have a look at part B. That's not what I intended to do. I'll pause this while I sort it out. Looks like you, again, know exactly what you're doing here. So now it's women, and they're Scottish. I honestly, genuinely had not read part B when I was talking about part A, I promise. But yeah, now we have Scottish women, still aged 25 to 34. Got the distribution, it's approximately normal, estimate the standard deviation, so you know exactly what you were supposed to use. 3 standard deviations on both sides. Basically, if you go from the middle and you go out, 3 standard deviations that way and 3 standard deviations that way, you basically, that's everything. It's not everything because they're asymptotes, but it's more or less everything. So what you've done is to go to the edge of everything, as in where the graph touches the x-axis, even though it doesn't really ever touch it, and you've said that it's 6 standard deviations from one to the other, so you've looked at it and said it's about 143 to about 182. That looks about right. I might have said slightly higher for the 180. Looks like, oh, maybe it's fine. It'll be fine. Like, the mark scheme's going to say all answers between this and this are fine, as long as it's roughly right. I think it looks roughly right. So then you've said that distance is 39, divided that by 6, and that's the standard deviation. That looks perfect. It might have been slightly wrong somewhere. We'll look at the mark scheme in a bit.